Good morning. My name is Farrokh Malihi. I'm a senior consultant with Fargol Research Group. The aim of this presentation is to provide an overview of technology of synthetic polymers. We'll discuss main characteristics, properties, applications, as well as certain methodology for characterization of these materials. The presentation will be in two parts. The first part is structural properties and characteristics, and the second part, methodology for characterization of synthetic polymers. This is the outline for this presentation. As you see here, the first part includes characteristics, properties of synthetic polymers, a brief on the synthesis and structural characteristics, and then we conclude with characterization methodologies, dealing with mechanical properties, morphology, molecular weight distribution, and particle size. Synthetic polymers are one of the key factors that contribute to the high standard of living in developed countries. They first entered the market after the Second World War, and their production has increased tremendously since in the second half of 20th century. Worldwide annual production of synthetic polymers is about 150 million metric tons. More than 50 million tons are produced and used each year in the US. Other production sites are Western Europe, particularly Germany, Japan, and in recent years, China, Southeast Asia, as well as the Middle East. The products made from polymers fall into three categories: plastics, rubbers, and fibers. And the end product of these categories include packaging materials, sheets, films, bottles, other packaging material, hoses, gaskets, appliance, housing, foam cushioning, fast food containers, fabrics for clothes and carpeting, and auto dashboard and other parts, as well as the tires, as well as many other applications. Synthetic polymers are inexpensive because the raw materials needed to make them are derived and sourced from petroleum, which is abundant and inexpensive. The key property that makes polymers useful is their physical strength, the ability to form different shapes for packaging, and to carry a load without becoming distorted in shape or breaking. The great utility of this material is due to a number of factors, including low cost, excellent combination of properties, and ease of fabrication into various products and applications. Another useful quality is their inertness to broad range of conditions, including moisture, pH, moderate temperatures, and physiological environment. The physical strength of organic polymers is due to the fact that they have very high molecular masses. Commercial polymers range in molecular mass from 20,000 to over 1,000,000 and are chosen according to a strength needed for each particular application. Chemical reactions between small reactive molecules called monomers yield long-chain molecules called polymers. There are about 30 major monomers that are in commercial use today. A sequence of chemical reactions, such as extending the length of an existing chain or the termination of chain growth, determines the structure of the molecule. Over the years, especially after the Second World War, chemists have learned how to design chemical reactions for polymerizing monomers so that they run with maximum efficiency, economy, and to produce polymers required for specific application. This photo here shows major commercial polymers, things like polyesters, polyurethane, polyacrylates, polyacetates, vinyl polymers, polyolefins, polyethers, and their source, which is mainly from petroleum or natural gas, and their final applications in molding materials, foams, and auxiliary additives. This is a schematic about the synthesis of the polymers, formation of a polymer chain by reaction. Uh, the steps include initiation, growth, chain growth, transfer, or termination. Formation of a polymer involves a large number of elementary chemical processes. Two different reactive groups here are shown that are engaged in the reaction. Blue and orange, they react with each other in a stepwise fashion, as shown in previous slide, to produce a polymer with a desired molecular weight distribution. There are several routes to the synthesis, and the key factors are arrangement of double bonds and different ways of connecting a monomer. In this case, a diene that leads to polymers with different properties. A problem with synthetic polymers is they are usually not biodegradable or biodegrade in limited amounts by microorganisms in the ground. Polymers accumulate in the environment, and that has become a recent environmental issue. Recycling of polymers is problematic because there are many different kinds that are used. One strategy for improved recycling is classification and identification of different kind and labeling them so that they can be separated and recycled separately. There are at least 6 categories. One is polyethylene terephthalate that are used in bottles for beverages and some personal care products. High density and low density polyethylene that are used in bottles and packaging and films. Polypropylene used also in packaging, polyvinyl chloride, and polystyrene. All of these are used as building materials, in packaging, and other applications. Another problem is the toxic gases some polymers produce when they are burnt, and these toxic gases during a fire can make it difficult to escape or put out the fire. We will continue in the second segment with characterization of polymers.